Hi, I'm Steve in front of the Crow's Nest restaurant here in Santa Cruz, California. Where we're going to go inside and ask people how they use math on their job.
Just
Follow me.
you know when you buy a hoodie and you buy it to like sit at home, yeah, you buy it bigger. But I think because it's that colour, you want to wear it out. Oh, thank you so much. It looks like a hoodie.
Hi.
Hi.
Do you women do you solve problems here at the restaurant?
Every day.
Do you use math?
Every minute of every day.
Can you give me an example?
Absolutely. For example, we have a reservation sheet here filled with numbers. These are all coordinated with the amount of seats that we have in the restaurant. We have to be sure at every point in time that we have enough availability to seat all of the people as well on our wait list. That's just one small example. As a server, you have to do a lot of math when it comes to calculating tips, as far as tips that people give you and tips that we also give to the kitchen, to the bussers, to the food, prep guys, everything like that. So we do math everywhere in this restaurant every day.
So one of the problems the manager at the restaurant mentioned was when a customer calls up and wants to make a reservation for a party of many people. Okay? You've got to figure out how many tables it's going to take and what kind of configuration you need in order to accommodate and put everybody at one long table. So typically a restaurant would have square tables with one person sitting on each side, and a square table would give you 4 people. So one table is going to give you 4 customers. If you add another square table right next to it, you add one person on each of the open sides, and that gives you a total of 6 people sitting around the new rectangular table. Notice that the first table gave you 4 people. The second table, adding the second additional table, only increased it by 2 for a total of 6. What happened to the other 2 people? Well, those are the interior sides, and they don't count. So you added 4 but took away 2. Okay? Let's go on with another table to show you that it's going to continue doing the same pattern. You're going to add 1 on each of the sides, and you're going to take away 1 in the interior. So the third table is going to give you 8 seats. Again, it only increased by 2. So depending on how many people call up, you're going to have to figure out how many tables you're going to need to set up in a long rectangular pattern, which is typically how we sit for dinner. Well, this is going to be a lot of work if you've gotten a lot of different odd numbers of customers calling up. And you can do a couple of things. Remember, whenever you have a pattern, you can always make a table. From a table, you can always make an equation. From an equation, you can always make a graph. So let's make this into a table. The tables are going to be our x value, or our input. The y value is going to be our output. And what we're trying to get to is enough information on the table so that we can make an equation. The equation that we're looking for in this particular case is going to be the slope-intercept form. Okay, and if you remember, that is y equals mx plus b. So the pieces that we need to fit into this equation are the m and the b. The m is going to be the growth, the difference in the change of the y. And the change here is constant. It's 2, increasing by 2. So our M is going to be plus 2. The B is going to be the y-intercept, and that is going to be the value of y when x equals 0. We don't have a 0 here, so I'm going to have to put it in here. What is the value of y when x is 0? Well, if we go down 1, the y is going to have to go down by 2, because we're increasing by 2 each time. So to go backwards, we're going to have to subtract 2. So it's going to go 8, 6, 4, 2. So the y value is going to be 2. When x is 0, y is 2. Okay? So that is going to be the b value. And it's a positive 2 in this case. Now we just bring down the x, have our equal sign equal to y. Okay, so there's our equation. Y equals 2x plus 2. Now if a customer called up and said we wanted a reservation for 20 people, how many tables are going to be required? Remember, the tables are the x. Okay? These are the tables. These are the customers. So if we've got 20 customers coming in, how many tables are you going to need? You simply just take the 20, plug it into the y. So let's draw this up here. Rewrite our equation with 20 being substituted for y, and that's equal to 2x plus 2. Now you can recognize this is going to be a two-step equation in order to solve for x. So the first step is we're going to get rid of the plus 2 by subtracting 2, and we're going to do that from both sides. So we have 18 on the left, and that's equal to 2x plus 0. The last step, we need to get rid of the 2 in order to have the x by itself. So this is a multiplication, so we're going to do the opposite operation, which is a division. So we're going to divide both sides by 2. So 2 over 2 is 1. 1x is simply x. And that's equal to 18 divided by 2 is 9. So 9 is equal to x. What does that mean? That means that up here, our x is 9, which is our tables. So we need 9 tables in order to fit 20 customers. Okay? You can't obviously be doing this every time a customer calls up and says he has a large party. But what you can do is once you've done it one time, you can make a graph. Okay? And your x is going to be on the bottom horizontal line, your y is going to be on the vertical line, and then you graph this. Starting with the y-intercept, when x is 0, y is going to be 2. When x is 1, y is going to be 4, so somewhere up here. Okay? And your graph is going to take this form. Okay? So you could look up the number of customers, start with the number of customers right here, and go over and then determine what the number of tables are going to be required. And that's how you use math in the restaurant business. Hope you enjoyed it.